Hi everyone and welcome to MathSux. This video is going to help you pass the Geometry Common Core Regents. We're doing this one question at a time. Here's question 32. A store sells colored craft sand in 3 different containers below. Container 1 is a square prism with a base length of 4 inches and height of 7.5 inches. So let's actually just draw these as we're talking about them. So we have container 1, and this is a square prism. And it's saying it has a base length of 4 inches. This is 4 inches, and then a height of 7.5 inches. Okay, so now let's look at the second container, container 2. It's a cylinder with a diameter of 5 inches and a height of 6 inches. So let's draw a cylinder with a diameter of 5 inches and a height of 6 inches. And then container 3 is a cone with a diameter of 7.5 inches and a height of 8.5 inches. Okay, and now for the question, it says if the containers are filled to the top, which container will hold the most sand? So we're basically trying to find the volume of each and then seeing which has the highest volume. So to find the volume of container 1, we're just going to multiply all these together, length times width times height. So when we do that, it's going to be 4 times 4 times 7.5. And we get 120. Okay. Now the volume of a cylinder is going to be pi r squared times h. So we know that the diameter is 5, but we need the radius, and the radius is just half of 5, so we know this is going to be 2.5 squared times the height, which is 6. So we could plug this in, 2.5, and we get 117.8. Let's round it to the nearest tenth. And now container number 3, volume of a cone is equal to pi r squared h over 3. So same thing, we're going to have to divide this 7.5 divided by 2 to get the radius. So that's 3.7 squared times the height, 8.5 over 3. So just using that formula, h over 3, 8.5 over 3. And now we can plug this in. And we get 125.2. So you can see here, comparing these 3 values, which is the highest volume, the highest number, and you can see that that's going to be the cone with 125.2. So we just need to write a little sentence here saying that container number 3 holds the most sand because it has the highest volume. And that's our answer. Question 33. Quadrilateral mic has vertices with the coordinates -1, -3, -3, 3, 5, 4, and 7, -2. Prove mic is a parallelogram and prove mic is not a rhombus. So as you can see, there's many steps to this question coming. So let's start with the first one. Let's first graph this with the coordinates they gave us for mic. So m is -1, -3, 1. Okay, so the first thing it asks us to do is to prove this is a parallelogram. So to prove something is a parallelogram, we're going to want to make sure that the opposite sides of this shape are parallel. Makes sense, it's a parallelogram. So we're going to want to make sure that this side is parallel to this side and this side is parallel to this side. So to do that, we're going to want to find the slopes of each side and make sure that they match. So these 2 slopes should match and these 2 slopes should match. So let's do this one at a time using the slope formula, and let's start with this right here, ik. So I we have is -3, 3, and k is 5, 4. So if we just use the slope formula, remember it's the change in y y2 minus y1 over the change of x, x2 minus x1. So we just need to think about this, and that's why I stacked them in this way. It's easy for me to see. So we could just do 4 minus 3, and then we could do over 5 minus negative 3, which will be 5 plus 3. So that's going to give us 1 over 8. So right here, this slope is 1 over 8. And now we're going to check it and make sure that this slope ME is going to be equal to the same thing, 1/8. So let's take M, which is -1, -3, and E, which is 7, -2, and just do the same exact formula with the slope formula. So y2 minus y1 over x2 minus x1. So this is going to give us 1 over 8 again. So good. So these two match. So we know that these two sides are in fact parallel. So now let's check these other two sides left. We have MI. So M, -1, -3, and I is -3, 3. The same slope formula. And we'll just do the same thing. It's y2 minus y1. So we have 3 plus 3 over -3 plus 1. So we get 6 over -2, which gives us -3. So the slope on this side is -3, and now we're going to make sure that this matches up with side KE. So this will give us -6 over 2, and we get -3 again. So this works out perfectly, and we know that Mike is a parallelogram. And so now we just need to write a little sentence. So we wrote, because opposite sides of quadrilateral Mike have the same slope, the sides are parallel, proving quadrilateral Mike is a parallelogram. Okay, so this takes care of the first part of our question. Now we need to prove the next part of our question. We need to prove that this is not a rhombus. So how do you prove something is not a rhombus? So we need to show something isn't a rhombus when consecutive sides are not equal to each other in length. So we need to show consecutive sides aren't equal in length. So to prove that, we're going to be using the distance formula on two sides next to each other. When we say consecutive sides, we mean like one side and then the next side. So we can choose any two sides. I'm going to start with I and M. So let's look over here first. I and M. So remember, I is -3, 3, and M is -1, -3. And this time we're going to be using the distance formula. So the distance formula looks something like this. D is equal to y2 minus y1 squared plus x2 minus x1 squared, and then this whole thing is under a radical. So it's a similar idea. We're going to be subtracting y2 minus y1, so -3 minus 3 squared plus x2 -1 plus 3 squared, and then this is all under a radical. So we get radical 40 for the length on this side here, IM. So I'm just going to do that in a different color. So this length here is radical 40. And now let's do the distance formula one more time for a consecutive side. So I'm going to pick IK over here. So I is -3, 3, and K is 5, 4. And we're doing that same distance formula. So you can see this is going to be 65, radical 65. So IK, this length is radical 65. So we can see that this is not a rhombus because these two values are not equal, and we need to write something up about that. So I'm going to put it on the side here. I wrote, since consecutive sides of parallelogram mic are not congruent, the quadrilateral is not a rhombus. And that's our answer. Question 34. A park ranger needs to secure 2 different trees with wire. A wire is to be attached from a stake in the ground to each tree. The wire is attached at 2 different heights and 2 different angles of elevation as indicated in the model below. The park ranger has 20 feet of wire. Does the park ranger have enough wire to secure both trees? Justify your answer. So if you look at where the wire is, it's the hypotenuse of each of these triangles, right? There's a right triangle here and a right triangle here formed by the 2 trees and the stake in the middle. So we want to make sure that there's enough wire, and it says wire here, that is formed by the hypotenuse of each triangle. So what we're going to have to do here is use SOHCAHTOA 2 times on each triangle to find the value of the hypotenuse, and then add the 2 values together to see if there's enough wire for 20 feet of wire, which is what he has. So let's start by drawing out this first triangle here on the left. This is a right triangle, and it's 4 feet, and we're trying to find the hypotenuse, and this angle is 24 degrees. So according to this angle, with reference to this angle, we have the opposite value, and we're trying to find the value of the hypotenuse. So if you look at our trig functions, opposite and hypotenuse, we know we're going to be using sine. So we have sine of 24 degrees is equal to the opposite, which is 4, over the hypotenuse, which is what we're trying to find. So now we're just going to use some algebra and cross multiply. And we get this value 9.83. So I always write out the whole thing because we're not sure. Sometimes when you round, you could get different answers. So that's why I write out the whole decimal even though it takes longer. So the value of this wire right here is 9.8. Okay, so that was our first triangle on the left. Now let's find the value of this hypotenuse on this other triangle on the right. So here we have another right angle. This is 3 feet. And then here we have 11.6 degrees. And again, we're looking for, I'm going to call this y for this value here, the hypotenuse. So this is the hypotenuse. And then we're given the value of the opposite, right, because it's opposite our angle. So again, opposite and hypotenuse, we're going to be using sine again. So we have sine of 11.6 degrees is equal to the opposite, 3, over the hypotenuse. So let's plug this in. And we get this number 14.919. So this value right here is 14. So now we need to answer our original question. Does the park ranger have enough wire? So we want to do is add these 2 together and see if they're less than 20 feet. So if we add 14.9195893 plus that value that we just got for the other hypotenuse, 9.83. So you'll see that we get this number that's 24.7. So we know that's over 20 feet. So this wire would have to be like 25 feet long for it to fit. So we're saying when we add these 2 together, it's greater than 20 feet. Therefore, the park ranger does not. So we're saying this number added together is greater than 20 feet, therefore the park ranger does not have enough wire. And that's our answer for this question. Question 35. Given quadrilateral carry with CA is congruent to RI, and CI is congruent to RA. So actually, let's just fill this in as we go. So CA, so this entire section CA is congruent to RI. CI is congruent to RA. AEI and LEH are drawn. Okay, prove HA over here is times EL is equal to LI times EH. So this looks like a proportion. This looks like this is cross multiplying from a proportion. So we know that we're going to have to prove these two triangles congruent. This triangle HAE and triangle IEL. So that's what we're going to be focusing on. And our method of doing that is that we're going to be proving that this whole quadrilateral is a parallelogram based on the opposite sides being congruent, which they gave us. And then we can use these lines, AEI and HEL. We can use those as transversals and then show these different congruent angles using that. And you could even use vertical angles over here. And we could show that these two triangles are similar to each other by angle. And then we can set up this proportion. So if this doesn't make any sense yet, don't worry. We're going to go over this one step at a time. So let's first start how all proofs start by writing the statements and reasons. So the first step to any proof like this is to just write out everything they gave you up here. So let's write out all the given. And the reasoning for that is that it's given. Okay, easy. Okay, so now the next step we're going to do here is we're going to mention that this quadrilateral is a parallelogram, and we know that because the opposite sides of this quadrilateral are congruent, which they gave us. So we know quadrilateral carry is a parallelogram, and that's because opposite sides of a parallelogram are congruent. Before we get into saying that this is X is a transversal and our angles, we're going to first mention that these opposite sides are parallel to each other. So we know they're congruent, and then because they're congruent and it's a parallelogram, they're also going to be parallel to each other. So opposite sides are parallel to each other. So we know that CI is parallel to AR, and CA is parallel to IR. And that's because opposite sides of a parallelogram are parallel. Okay, so now we could start talking about the angles. So if these are parallel and opposite sides are congruent, now we can say that angle AHE, so over here, is going to be congruent to angle ELI, right? Because this HEL line acts as a transversal, cutting two parallel lines and creates congruent alternate interior angles. So angle AHE is congruent to angle ELI. And we can also say, so if that's true, then this is also true. Angle EIL is going to be congruent to angle HAE. And these are for the same reasons. Parallel lines cut by a transversal create congruent alternate interior angles. So now we could say these two triangles are similar to each other by angle. So we have triangle HAE is similar to triangle IEL, and this is by angle. And now we could set up a proportion where cross multiplying this would make sense. So we can do HA over, like if you look at this, we kind of want to do the opposite. So we know HA will be diagonally opposite EL, and then we have LI to EH. So if you look at this, we have HA over LI. So that lines up, right? Because we have HA, so we have our two angles to LI, or the two angles of the bigger triangle, is equal to EH, this shorter leg here, with our small angle with EL. So everything matches in proportion. This looks good. And we know that this is true because corresponding sides of similar triangles are in proportion. And now our last step, because we need to prove this to begin, that's what they're asking us to do. So now we could just cross multiply, and we have HA times EL is equal to LI times EH. And the reasoning for this is product of means equals product of extremes. So this is the last question on our math test. I hope this helped you. If you have any questions, let me know. Good luck on your test and happy calculating.